Tutor Pauly here, back with another question. Calculus and u substitution. We have the integral here in the pink of an interesting function. It's of exponential and trigonometric. And so we have to figure out what u and du is. The goal of u substitution is to create a whole new integral in terms of u that's easier to integrate. So we have to find both u and its derivative du. Okay, so it takes practice. I know that u is going to be cosine of x, because if we were to differentiate cosine of x, you'll get negative sine of x dx. And I see both of those things in our integral, okay? And that's the same thing as negative 1 times sine of x. And there they are. But you might be asking, wait a second, I don't see sine of x, or negative 1 times sine of x, I only see sine of x. Well, if it's off by a constant, we can fix that problem, okay? If it's more fundamental, if the thing isn't there, then it won't be, that will be the incorrect selection for you. For example, I know u not to be sine of x, because if du were cosine of x dx, that would put the dx in the denominator. But look at our integral. Dx is on top. Dx is over 1. All right, so we're going to make our substitutions here. We first have to solve for dx, okay? And we get dx equals du over negative sine of x. So now we put that in. And we're going to replace the cosine of x in the green with u, all right? And now we can start canceling things out. The sine of x's will cancel. And so you're just left with negative 1 over e to the u du. We have a whole new integral here in terms of u and du only. No more x's. Notice I'm not writing the bounds in our integral. It's still a definite integral, but those bounds were in terms of x, not u. So if you wanted to write the u bounds, you would have to plug them in and find them. Remember, at the top right, u equals cosine of x. You can find the u bounds that way, but I don't think that's necessary. So the next step would be to use our rules of exponents, bring e to the top. So now we have negative 1 times e to the negative u, the integral of that. Well, if we think about it in this way, what can you differentiate to get negative e to the negative x? Okay, I say that because we think of oftentimes in terms of x rather than u. So, well, e to the negative x, you can differentiate to get negative e to the negative x. And the reason for that is e to the x, or e to the negative x, that's the derivative of the outside. The derivative of the inside, negative x, is negative 1. So that's negative e to the x times negative 1. So the integral of negative e to the negative u is e to the negative u. All right, and now we have our, we've integrated it. We started with x's, so let's return to whence we came. Okay, remember, u equals cosine of x, and now it's e to the negative cosine of x. If you were to differentiate this, by the way, you would get what we started with, the sine of x over e to the cosine of x. And we are going to plug in our bounds. The first bound was 0. The second bound was pi over 4. E to the negative cosine of 0 is e to the negative 1. And using the unit circle, you should know, if you don't already, that cosine of pi over 4 is root 2 over 2. So that's negative root 2 over 2. And we could just put it in the denominator there, make them positive, and that would be an exact answer. You could also plug in, and you get negative 0.125. I hope this helps.